Somewhere out there, right now, it is raining, not water, molten iron, blown sideways by a wind fast enough to strip a mountain flat. There's a world where the clouds are made of the same mineral as rubies. There's a star where the rain is on fire, and a single drop is wider than Ireland. And in the freezing dark of our own solar system, on 2 planets you learned the names of as a child, it has been raining solid diamonds for 4.5 billion years without pausing once. We're going through every kind of rain in the universe, 11 skies, starting with the one outside your window tonight, and ending with the hardest storm we know about. It gets stranger the further down we go. Number 1. Earth water. We start at home, with the only rain on this entire list you could stand in and survive. And even this one is stranger than you've been told. Ask anyone to draw a raindrop, and you get a teardrop, round at the bottom, pointed at the top. That shape does not exist. A small raindrop is a near-perfect sphere, pulled tight by its own surface tension like a water balloon in freefall. Grow it bigger, and air pressure flattens the bottom until it looks like a tiny hamburger bun tumbling through the sky. Push past about 5 millimeters across, and the drop simply can't hold itself together anymore. It shivers apart into smaller ones on the way down. Every heavy shower you've ever run through was a swarm of falling bread rolls that kept exploding. And here's the part almost nobody knows. Water vapor on its own is remarkably bad at becoming rain. It needs something to grab onto, a speck of desert dust, a grain of sea salt thrown off a breaking wave, a fleck of soot, sometimes a single bacterium riding the wind. Almost every raindrop that has ever hit your face was built around a piece of dirt. That's the recipe. A liquid, a way to cool it, and something for it to cling to. Hold on to that recipe, because it's about to be run again with completely different ingredients, starting with a world where the snow falls in cubes. Number 2. Mars, the snow that falls in cubes. Mars has weather, thin, starved, half-dead weather, but weather. Clouds drift, seasons turn, and in the deep polar winter it snows. 2 different kinds, in fact. There's ordinary water ice snow, which the Phoenix lander caught in 2008 by shining a laser up into the clouds and watching snow fall out of them about 4 kilometers above its own head. And then there's the other snow, the one that shouldn't sound possible. Carbon dioxide, frozen air, dry ice, drifting down out of the sky at the Martian poles, cold enough to burn your hand off if you caught a fistful. That second kind is the specimen worth putting under glass. Water freezes into 6-sided crystals. That's why every snowflake you've ever seen has 6 arms. Carbon dioxide doesn't. Its molecules stack into cubes. So a Martian polar snowfall isn't a drift of feathery stars. It's a blizzard of microscopic dice, tumbling flat-faced through the dark, each one roughly the width of a red blood cell. But here's the detail that turns Mars melancholy. That water snow the Phoenix lander watched, it never landed. The air below was so dry that the flakes evaporated in mid-fall and vanished before they touched the ground. There's a word for rain that dies on the way down: virga. Mars has storms that arrive and never finish, which raises the obvious question. If a world can have rain that never lands, what does a world look like where the rain actually pools and floods and carves rivers, and it still isn't water? Number 3. Titan. Rain in slow motion. Saturn's biggest moon is the only other place in the entire solar system with liquid on its surface, and the only other place where it rains onto that surface from clouds overhead. The liquid is methane, natural gas, the stuff that burns blue on your hob. At minus 179 degrees Celsius, water on Titan is frozen harder than granite. The bedrock there is ice, so methane takes water's job entirely. It pools into seas larger than any of the Great Lakes, evaporates, forms clouds, falls as rain, and carves branching river valleys into an ice landscape, a complete weather cycle, running on fuel instead of water. Now put yourself under that sky, because this is where it gets beautiful. Titan's gravity is about 1/7 of Earth's, and its air is thicker than ours. Both of those things fight the falling drop. So Titan's rain comes down at around 1.5 meters per second, roughly the speed of a snowflake here, and about 6 times slower than a raindrop on Earth. And the drops are enormous, up to 1 centimeter across, twice the size of anything our sky can hold together. Picture it. Fat, sluggish, gas station-smelling globes of methane, drifting down through orange haze so gently you could watch an individual drop fall for a full second before it landed on you. It rains in slow motion out there, and it barely rains at all. Models suggest some regions of Titan wait decades between storms, but at least on Titan the rain arrives. On the next world, it has been trying to land for 4 billion years, and it has never once made it. Number 4. Venus, the acid that never lands. Venus is wrapped from pole to pole in an unbroken deck of cloud about 50 kilometers above the ground. From outside, it's the brightest, softest-looking thing in our night sky. Those clouds are concentrated sulfuric acid, the same compound sitting in a car battery, except here it's an entire planetary weather system, and it rains. Droplets of acid condense up in that deck and start to fall, exactly the way water does here. They never arrive. Venus gets hotter the lower you go, and it gets hotter fast. The surface sits at around 465 degrees Celsius, hot enough to melt lead in an open dish. So somewhere around 25 to 30 kilometers up, still miles above the rock, every single drop boils back into vapor. The vapor rises, it cools, it condenses, it falls again, and it evaporates again at the same altitude, forever. That's Virga, the same thing Mars does with snow, but Venus does it on a planetary scale, permanently, with acid. There is a layer of sky on Venus where it is always raining and a surface below it that has been bone dry for longer than complex life has existed on Earth. A storm that has been falling for 4 billion years and has never touched the ground once. So far though, every one of these is a liquid falling through a gas. Take the next step out to the giant planets, and the rain stops being liquid or solid and starts being something in between. Something with a name that sounds like a joke until you learn what it does. Number 5. Jupiter Mushballs. In 2020, scientists working with NASA's Juno spacecraft had a problem. Ammonia was missing from Jupiter, not from the very top of the clouds. That would be easy, but from deep down, 150 kilometers below the visible cloud tops, in patches all over the planet. Something was reaching into the atmosphere and dragging the ammonia away. The answer they landed on is one of the strangest objects in this catalog, and the team named it exactly what it looks like, a mushball. Here's how one is born. In Jupiter's violent storms, updrafts hurl water ice crystals upward into a band of atmosphere, sitting at roughly -90 degrees Celsius. Ammonia gas up there behaves like the antifreeze you pour into a windscreen washer. It drops water's freezing point so hard that the ice partly melts, even in that cold. What you get is a slush, 2 parts water, 1 part ammonia, sloshing at 90 below. That slush glazes over with a shell of ice, gets thrown up and down through the storm, gathering more layers exactly the way hail forms in a thunderstorm here, and grows until nothing in the sky is strong enough to hold it up. Then it drops. And on Jupiter, dropping doesn't mean a few kilometers to the ground. There is no ground. Mushballs fall for hundreds of kilometers, hauling the missing ammonia down with them, and only evaporate when the air around them finally turns warm enough to eat them alive. Ice-crusted slush balls, falling through a sky with no floor. In 2025, a Berkeley team went back through Juno's radio data and found the idea holding up. But Jupiter's neighbor does something even harder to picture, because on Saturn, it isn't the weather that rains, it's the air itself. Number 6. Saturn, helium rain. Saturn has a heating problem, and it took decades to work out why. The planet radiates roughly 2.5 times more energy back into space than it receives from the sun. It is glowing with heat that has to be coming from somewhere inside. And separately, there was a second puzzle. Saturn's upper atmosphere holds noticeably less helium than it should, given what the sun and the rest of the solar system are made of. Heat appearing from nowhere, helium vanishing to nowhere. 2 mysteries, 1 answer. Go down far enough into Saturn, and the hydrogen stops being a gas. Under crushing pressure, it turns into a hot metallic liquid. Hydrogen behaving like mercury, dense and electrically conducting, and helium will not mix into it. The two separate the way oil separates from vinegar in a jar left on the counter, and the helium beads up into droplets. Then those droplets fall, not for a few kilometers. They rain down through thousands of kilometers of liquid metal toward the core, and every drop that falls converts its own height into heat. The same way a stone dropped down a well arrives at the bottom, slightly warmer than it left. Do that with an entire planet's worth of helium for billions of years, and you get a world quietly keeping itself warm from the inside by raining a part of its own atmosphere into its basement. Saturn is not being heated. Saturn is falling. That's rain that dissolves the ordinary difference between air and ocean, but at least it's still made of gas. What happens when you take a planet and shove it so close to its star that the ground itself starts to evaporate? Number 7. K2-141b. Rock rain. Meet a lava world. K2 orbits so tightly that a year there lasts about 7 hours, and it's tidally locked, one face permanently roasting, one face permanently in the dark, no sunrise, ever. The day side sits near 3,000 degrees Celsius, hot enough that roughly 2/3 of the planet's surface is a magma ocean about 100 kilometers deep, and the atmosphere there isn't gas in any sense you'd recognize. It's vaporized rock, sodium, silicon monoxide, silicon dioxide. The stone floor of the planet boiled straight into the sky, exactly the way a puddle becomes cloud on Earth. So the cycle runs. Rock evaporates on the hot side. Supersonic winds, modeled at over 5,000 kilometers an hour, several times faster than sound, drag that rock vapor across the terminator into the freezing night side. There it cools, condenses, and falls. Rain made of stone, dropping into a black ocean of lava, which then flows sluggishly back around to the day side to be boiled into the sky all over again. It's the water cycle from a school textbook. Same diagram, same arrows, evaporation to condensation to precipitation. Somebody just swapped out the water for rock and turned everything up until it glowed. And K2 isn't even alone in this. There's a blue world called HD 189733b, where the same broad chemistry is thought to blow silicate particles, the mineral family that makes glass, sideways through the atmosphere at 7 times the speed of sound. Melt stone and it rains stone. So melt the one thing we build our strongest machines out of, and you get a sky that would kill you on contact. Number 8. WASP-76b. Iron Rain. In 2020, astronomers using an instrument called ESPRESSO on the Very Large Telescope in Chile watched a planet 1,200 light-years away and found something in its atmosphere that had no business being a vapor: iron. WASP-76b is a gas giant orbiting so close to its star that its day side reaches around 2,400 degrees Celsius. That's not just hot enough to melt iron, it's hot enough to boil it, to lift metal off a world and carry it into the sky as gas. Like all these tortured worlds, it's tidally locked, so that iron vapor gets swept by ferocious winds around the edge of the planet into the permanent night side, where temperatures drop by something like 1,000 degrees. And that's the exact moment the metal gives up. The iron condenses out of the sky and falls as rain, actual droplets of liquid iron, forming along the boundary between eternal day and eternal night, falling forever into the dark hemisphere of a planet that has never once seen the sun set, because on WASP-76b, it never rises. Sit with the physics for a second. On Earth, the rain is the gentlest thing our chemistry can produce. It's the same substance as ours, falling at walking speed. On WASP-76b, the sky produces the material we make anvils and ship hulls out of, and drops it in liquid form on a wind fast enough to flatten a mountain range. You'd think metal would be the ceiling. It isn't. Because if you can get a sky hot enough to boil iron, you can get one hot enough to boil the ingredients of a jewelry shop. Number 9. HETP-7b. Ruby and Sapphire Rain. 1,000 light-years from here sits HET, a gas giant with a day side sitting somewhere around 2,500 degrees Celsius. In 2016, astronomers led from the University of Warwick found something odd in years of Kepler telescope data on this planet. The brightness of its atmosphere kept shifting, as if enormous cloud banks were forming, sweeping around the planet and dissolving. Clouds on the cool night side, blown around toward the searing day side, where they evaporate and then reform and go again. Weather on a scale we can detect across 1,000 light-years of empty space. The interesting question is what those clouds are made of. At that temperature, the best candidate is corundum, aluminium oxide, one of the hardest minerals there is, which is the part that stops people. Corundum is the mineral of rubies and sapphires. It's the same stuff. The only difference between the two is a trace impurity that slipped into the crystal as it grew. A whisper of chromium turns it red, and we call it a ruby. Iron and titanium turn it blue, and we call it a sapphire. And on HAT P7b, the honest reading of the data is that this mineral is condensing high in the atmosphere and falling out of the sky. Not a metaphor, not a headline stretch, a genuine chemical inference. A planet with weather systems raining out the raw material of every engagement ring on Earth into a sky no one will ever stand in. Every rain so far, though, however violent, has needed a planet to fall on. The next one falls out of something with no surface at all, and you can see it from your own garden. Number 10. The Sun. Coronal Rain. The Sun's outer atmosphere, the corona, the pale halo you can only see with the disk blocked out, sits at over 1,000,000 degrees Celsius, which is already absurd because the visible surface underneath it is a mere 5,500. The atmosphere is hundreds of times hotter than the thing it's wrapped around, and physicists have argued about why for the better part of a century. Sometimes, though, a patch of that million-degree plasma cools. Not much by solar standards, down to around 10,000 degrees, but that's enough to change everything. The plasma condenses the way steam condenses on a cold window, and it clumps into denser blobs. And then, because the sun has gravity like anything else, those blobs fall. They don't fall straight. The sun's magnetic field arches out of the surface in vast loops, and the falling plasma is trapped on those loops like water running down the inside of a rope. So it curves down enormous burning arches and slams back into the surface at something like 100 kilometers per second. Here is the scale that breaks people. This is called coronal rain, and it has been filmed. A single one of those droplets can be hundreds of kilometers across, one raindrop bigger than Ireland, glowing, falling at over 200,000 miles an hour, down an arch of magnetism taller than the Earth. That's the fiercest rain in the solar system, but it isn't the strangest one. For that, we go back to where it's coldest, and to the only rain on this list that never evaporates, never breaks apart, and never comes back up. And the last one, Neptune and Uranus, the diamond rain. Uranus and Neptune are the two planets nobody talks about. One spacecraft has been to either of them once, in 1986 and 1989, and it didn't stop. They are the least explored major worlds we have. And underneath those flat blue faces is a storm that has no equal anywhere in this catalog. Both planets are stuffed with methane, one carbon atom holding 4 hydrogens, the molecule that gives them their color. Sink down through the atmosphere, and the pressure climbs brutally. Thousands of kilometers in, it reaches a point where methane can no longer stay intact. The molecule is torn apart, the hydrogen is stripped away, and the leftover carbon is squeezed so hard it has only one place to go. It crystallizes into diamond. For decades, this was theory. Then, in 2017, a team led by Dominic Krauss took a thin sheet of ordinary plastic, hydrogen and carbon, the same 2 ingredients, to the SLAC National Accelerator Laboratory in California, hit it with laser-driven shockwaves to briefly recreate the inside of Neptune, and watched with an X-ray laser as nanodiamonds formed in real time. They didn't theorize it. They made it happen on a bench. And then those diamonds do the only thing they can do. They sink down through thousands of kilometers of hot, dense, half-crushed fluid toward the core, drifting for what may be thousands of years per stone. Here's what makes it more than a party fact. In 2024, a follow-up study at SLAC found the diamonds form at lower pressures than anyone expected, meaning the rain starts shallower, and there's far more of it. And as all that solid carbon sinks through electrically conducting fluid, it stirs. It drags currents behind it. That churning may be part of why Uranus and Neptune have the most lopsided, chaotic magnetic fields in the solar system, tilted at crazy angles, offset from the center, unlike anything Earth or Jupiter does. The weather might be wiring the planet. So look at the whole shelf now. Every specimen in this video is the same 4 steps. Something evaporates. It rises, it cools, it falls. That is all weather has ever been. On Earth, on Titan, on a lava world boiling its own crust into the sky, on the surface of a star. Change only the ingredient and the temperature, and the identical process gives you a summer shower, or a slush ball, or liquid iron, or a gemstone. And on 2 cold blue planets you could point to tonight, that same simple process has been quietly manufacturing diamonds and dropping them into the dark for 4.5 billion years. A rain with no ground to land on, no season, no end, and no one there to hold out a hand and catch one. The next time it rains and you find yourself irritated by it, remember what you're standing in: the softest, kindest, most survivable weather in the known universe, made of the one substance on this entire list that won't burn you, dissolve you, or crush you. We got the gentle version. Almost nowhere else did. If you made it all the way down to the bottom of Neptune, comment diamond so I know which of you went the distance. Leave a like to tell the algorithm you came back up, and the next specimen in the archive is already waiting.